Hi everyone. So this is our very first video math lesson. And I'm using an app called Explain Everything to make this for you today. And I really hope that it works because I think it would be really great for you to be able to pause and rewind and rewatch math lessons as we continue our math learning this year. So if you have any feedback or any thoughts about how this worked, I'd love if you would write them for me on Google Classroom on this assignment. That'd be awesome. So our first unit this year is patterning. And I just wanted to kind of start this lesson by asking you to take a minute and just think about what you remember from patterning last year. And it might be a lot, and it might be hardly anything at all. And either way, that's good. We're going to get you caught up to speed and hopefully get everybody to a place where they're feeling good about patterning. So I wanted to start today with a lesson about how we can get from a visual representation of a pattern like this to an equation that can help us find out more about that pattern in the future. So just a quick little review here. I'm going to get my little pointer. So in this example, we kind of have two parts of the pattern. We have the term number that tells us what stage of the pattern we're at. So 1, term 2, term 3. And then we have the value part of the pattern. So this is how many tiles in this case. We're working with tiles. We have at term 1. So as you can see, we have red tiles and blue tiles. And I'm going to write this on here for you. The blue tile is what we call a constant. And it stays the same for every single term. It's only the red tiles that are changing. And as you can see, they're getting bigger, they're growing each time. So this is a growing pattern. Blue is our constant, and red is our coefficient. And I'm hopefully going to get better at writing on this as time goes on. So those are kind of the parts of this pattern that we're starting with today. So now we can kind of name things. I'll tell you that's the term number. I'll just use a number sign so I can fit it there. So from here, we are going to figure out what the pattern rule is. So we're going to state the pattern rule. So when we look at this, we can see that it's growing. So we know we have to add something on or multiply something on or do something to the constant that's going to make the pattern grow. So I can look from term 1 to term 2, and I can see that the difference between this picture and this picture is 4 tiles. So we're adding 4 tiles. But the pattern rule is not just add 4. If it was, then the first term would actually be 4. We need to make sure that whoever is looking at our description of the pattern knows that they have to start at 5, because there's 5 tiles total there, and add 4 each time. So this is our pattern rule. Another name that people sometimes use for the pattern rule is the recursive pattern rule, which basically just means that it's a pattern rule that tells you the start number of a pattern, term 1 of a pattern, and how the pattern continues. So that's one way to describe a pattern. Once you have your pattern rule, something you might be asked to do or do on your own in order to solve the next part of a question about a pattern is to create a table of values so that you can see your pattern really quickly, really efficiently, and it's clear what the term number is and what the value is for each term number. So I'm going to draw you a little table of values here, and you probably have seen one of these before. So this side is going to be your term, and sometimes we also call that X. Okay, and then this is going to be your value, and sometimes we call that Y. So this is a table of values, and I'm going to show you how to write for this pattern that we have what your values are for all the terms up to 10. So we know we start at 5, and we know we add 4 each time. So from 5, we go up to 9 tiles. And from 9, we go up to 13 tiles. And so on and so on. And I will pause and write the rest there for you so you can see. Okay, so there you go. That's the first 10 values in this pattern. And that's just using the pattern rule or the recursive pattern rule that we talked about in the beginning, which is start at 5, add 4. And that didn't take me very long. But if I were to ask for something like the 100th value in this pattern, that might take a little bit longer. And so I'm going to show you how to take this table of values or take the image with the pictures of the tiles from before and turn that into an equation that will help you find the value of any term. Okay? Before we do that though, I just want to let you know that something I forgot to tell you a second ago is that so the term is sometimes referred to as X. It's also sometimes referred to as N, as in the term number, and it's always a lowercase n. Okay, and that's how we're going to refer to it in today's lesson. All right, let's figure out how to find any value. So the name for the equation that we're going to use to help us find any value or any term in a pattern is called a relationship rule or an explicit pattern rule. Okay, so an explicit pattern rule or a relationship rule is a rule that tells you how to get any term in the pattern without listing all the terms before it. All right, so what we're going to do to figure that out is we have to remember back to when we talked about what the constant was and what the coefficient was. So if you remember back to that picture, I'm sorry that it's not here, but if you rewind back to that picture, you'll remember that the constant was the blue tile, and we had one of those, and the coefficient was +4 because for every term number we were adding 4 red tiles. So this was the blue, and this was the red tiles. So in order to write a relationship rule, we have to think about how we can use math language and math symbols to represent our table of values and the images of the tiles that we had before. So what's actually happening here, if we think of the table of values, which I'll quickly just write a couple terms over here. So there's the term number and there's the value, and we'll do 4 here. So we started at 5, and then we went to 9, and then we had 13, and then we had 17. And so what's happening, we're going up by 4 each time. We're also we have to look at the relationship between the term number to get to the value number. And so how could we get from 1 to 5? Well, we could multiply 1 by 4 and add 1, but then we have to think about, would that work for 2 to get to 9? So 2 times 4 is 8, plus 1 is 9. Would it work for 3? 3 times 2, or sorry, 3 times 4 is 12, plus 1 is 13. So I have a feeling that it's going to work for 4 as well. So we know from testing that 4 multiplied by the term number plus our constant, which is 1, is going to equal our value. So this is a growing pattern. It only has one rule to it, and that's add 4 each time. Start at 5 when you start at 5. And so we can probably guess that we'll be able to use this kind of a formula. So the coefficient multiplied by the term number plus the constant in order to find what the relationship rule is for these kinds of patterns that grow by a certain number each time. Now, this is going to look a little bit different when we start getting into multi-step patterns, but for today, I just want you to think about this kind of a relationship rule, okay? So now we know that, let's try and apply that. So what would the 56th position be? Well, we have this handy dandy equation now. So we don't have to use a table of values and count up 4 every single time till we get to 56, which might take us until dinner time. And I'm not really here for that. So, I'm going to do this in black because it'll be a little bit easier to look at. So we know our equation is 4n plus 1 equals y. So the term number we want to find is 56. So we just plug that into our equation. So 4 times 56 plus 1 equals y. Okay, so if we remember back to BEDMAS, important, we remember that the first thing we have to do, there's no brackets, really. This could be just a multiplication sign in there. There's no exponents, there's no division, but there is multiplication, and it comes before the addition. So what we're going to do is we're going to do our multiplication first. So what's 4 times 56? It's 224. Plus 1 is 225. So that is your 56th position. We're going to write that in words because then it makes it really clear to whoever's reading this what our answer is. So the 56th position or term would be 225 tiles. Awesome. Okay, so here's sort of the last layer we're going to talk about with taking a pattern, turning it into an equation, and then using that equation, applying it to the pattern to answer questions about the pattern. And so this question, could you build a position in this pattern with exactly 154 tiles? Why or why not? So 154 tiles here is talking about a value. So in our table of values, we have our term numbers and we have our values or y. And so 156 tiles would be somewhere in here. but we don't know where because it hasn't told us which position it would be. So we have to use our equation from before to solve this, which we can absolutely do. We have those tools. So our y value in this case is, like I just said, 154. So we're going to write that down. 4n plus 1 equals 154. And then we're going to remember our handy dandy BEDMAS. And just like before, we're going to do our multiplication first. So first of all, we've got this multiplication here, and we need to get rid of it so that we can isolate our n. And so what we're going to do is the opposite of multiplication, which is to divide by 4. We're going to do that to both sides. So when we divide, we get rid of this 4 because we have canceled it out. And 154 divided by 4 is 38.5. And so now, again, we've got plus 1 here before we can isolate that n. So we have to actually subtract 1 in order to be able to cancel that out. And 38.5 subtract 1 is 37.5. Okay, so now we figured out what the position would be if we had 154 tiles, and we see that no term can be a decimal, right? They're whole numbers every time. Our terms are always 1, 2, 3, 4. There's no decimals there, and so on. So the answer to the question, could you build a position in this pattern with exactly 154? No, you could not. "154 tiles would be position 37.5. So if you had 154 tiles, you could really only make up to position 37 because we would round down. So there's a little bit more. We have a few more tiles because we could get to 37.5, but our positions are only whole numbers. So we're not going to do that. Okay? So this is the end of our lesson, which is a bit of a review about using patterns to create equations and then using those equations to find out more about the patterns that we're looking at. So what I would like you to do now is if there's something you didn't understand, you can go back and rewatch it. But there's another file in the Google Classroom that you can open to answer some questions. Okay? Thanks, everybody.